Hi there, thanks for joining us. This is Space Nuts. My name is Andrew Dunkley, your host, and on this week's episode, we're going to visit an old friend, which visited last in 1986, I think it was, and it's about halfway to coming back and visiting us again. We'll tell you all about that soon. And a first-of-a-kind stream of stars has been discovered, and they can't really figure out why it exists. As with most things in space. We'll also answer some audience questions about the boat, about temperatures in space, about galaxy collisions, and lo and behold, someone wants to finish the year with a dad joke, and we will indulge him. That's all coming up on Space Nuts. I thought I might start with a different theme, just, to get into the Christmas spirit, Fred. But, just so that no one in the podcast world gets upset, we better do the proper one.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And here he is, the man of the moment, Professor Fred Watson, astronomer at large. Hello, Fred.
Space Nut at large. Nice to see you, Andrew. How are you?
I'm doing okay in this horrific heat we're having. We're into the second, possibly third week of a heat wave. Temperatures not getting below 100 in American speak. But we'll get some relief in a couple of days when it drops to 36 degrees centigrade, which is still in the 90s. Other than that, quite well. This is our last show not last show for the year, but the last fresh show. We're just going to run a couple of repeats between now and the new year, and then we'll get back together pretty swiftly. Not like last year when we took 2.5 months off. But yes, this year we'll just a couple of weeks. Though. Yeah, well, there were all sorts of things going on then, weren't there?
There were, yes, that's right, there were.
Now, let's get straight into it because I'm intrigued by this particular story because we have a Halley's Comet update. What's happening with Halley's Comet?
So the reason why we've got an update is that a few days ago, on the 8th of December, which, by the way, is also Sibelius's birthday, I just thought you'd like to know that, the composer, it's the 8th of December marks the point at which Comet Halley is furthest from the sun. So Comet Halley has got this highly elongated orbit, really stretched, and it's now, in fact, just to give you the distance, it is 30.5 astronomical units away. And as you know, an astronomical unit is 150 million kilometers. It's the distance between the Earth and the sun. So it's 35 of those, 35 times as far away as the Earth is from the sun. Do you know off the top of your head, Andrew, how far away Neptune is in those units?
Yes, I do.
Good. Well, I won't ask you then because I do too.
I don't, actually. I don't.
It's 30 astronomical units is the orbit of Neptune. And so Halley is way beyond that. It's, 5 Earth orbit radiuses from further on than Neptune, 35 astronomical units. So it's on its way back into the inner solar system. It will reach the sun or have its closest point to the sun, closest approach to the sun in 2061. In fact, it will be visible from the 19th of June, 2061. Put it in your diary. And perihelion, that's the nearest point, is on the 28th of July, 2061. I am not expecting to see it, but I'll be delighted if I do, because I'm 100 and something.
Yeah, I'll be well into my 90s, so I don't expect to be seeing it either.
Oh, yeah.
But look, never say never. Never say never. Now, I'm intrigued by this because Halley's Comet's probably the most famous comet in history. But in 1986, it was rubbish. It was just terribly disappointing. We were all revved up for it. And it turned up, and you could barely make out this fuzzy blob. which is all I saw of it myself.
Do you know why you were all revved up for it, Andrew?
I was revved up for it because it's Halley's Comet, and I expected to see this flash of this big fireball in the sky, but that's not what it was.
Yeah. No, you were part of the problem because what revved everybody up for it, everybody up was the media. Yeah. Because astronomers, and I wasn't personally involved with this, but back in 1910, the last time it came around, astronomers said it is going to be rubbish in 1986. And the reason for that is that when it was, yeah, absolutely. It's well known where in the sky it's going to be in the future. And in 1986, as predicted back in 1910, it was on the other side of the sun from the Earth when it was at its brightest. So, you've got this object which is basically, more than the radius of the Earth's orbit away. So it was always going to be feeble. And yeah, they said in 1910 was a brilliant appearance. And in fact, the Earth went through the comet's tail, which caused all these quack medications for people to protect themselves against the comet's tail, because already people knew that comets' tails contain cyanide. They do. Right. And cyanide, we're all going to die. So you must take Dr. Spock's magic medicine to stop you dying. So yeah, it was a huge thing in 1910. But in 1986, we were all saying in the world of astronomy, don't bother, it's going to be rubbish. But the media really jacked it up.
Is that because of the angle that it came in from? I read something about the fact that it was on the wrong side of the sun for our position to get a good look. And in 2061, it's actually in a much better place.
That's right. It's far better place. So it was at its brightest. It was on the other side of the sun from us.
Right.
And yeah, so it was always going to be a fizzer. I did see it. Curiously, when it was at its closest in 1986, I was in the UK, even though I was working here in Australia. But I came back and there was a total eclipse of the moon, which meant that despite it being a full moon, the moon effectively disappeared because it was in the Earth's shadow. And we could see Comet Halley that night. So there's a total eclipse of the moon.
Oh, that would have been amazing. Occasion. Yeah. I've only seen a couple of comets in my life, and there was one, I can't remember what year it was, but it was spectacular on the southern horizon, or western, I can't remember. But
it was early in 2007.
Yeah, I remember because it was around Australia Day, January 26th. I was at a function for Australia Day, and we were all having dinner, and we all went outside to look at the comet when the sun set, and oh, man. But no digital cameras back then, so no one got a photo of it. But it looked amazing. So which one was it again, sorry?
Yeah, Comet McNaught. So Rob McNaught, who works alongside me at Siding Spring Observatory, we were colleagues there. He was also an avid comet discoverer because, in fact, that was his job. He was paid from NASA via the Australian National University to operate a telescope that was looking for near-Earth objects, things that might collide with Earth. And so he discovered, as well as things that might collide with Earth, he discovered many things that wouldn't. And that certainly the most spectacular was Comet McNaught. He discovered several, actually, but that particular one, which was brightest at the beginning of 2007, was utterly spectacular. And you might remember it had what were called striations in the tail. It had these stripes in the tail, which were as clouds of dust were emitted from the comet. It was an absolute cracker.
It was.
Rob's name lives on because of that. Rob's still around. He lives in Coonabarabran, but he's not very active these days in the comet discovery world.
Yeah. So that one was Comet McNaught, and the next one he discovered was Comet Mc1, and then Comet Mc2.
I'm sure he's... yes, I will tell him next time I see him.
He'll tell me. That's what will happen.
It's when he probably got to Comet Mc15 and maybe even Mc16. He's discovered plenty. In fact, there is one... if I remember rightly, I think there is McNaught Watson as well, because we jointly...
Yeah, I remember that.
What's
Now, one other thing about this Halley's update is I believe it's really slowed down as it reaches that furthest point from the sun, because when it passes the sun, it's going at a hellish pace. But when it gets back out there past Neptune, it goes, "Oh, I'm too tired. Just going to have a rest." I suppose it has to slow down and turn around, doesn't it?
No, it's Kepler's Third Law, which says that, no, wait a minute, it's the area swept out, I can't actually remember it, but it basically says that things move fastest when they're closest to the sun and slowest when they're furthest away, and the speed just varies. It's all about the way it sweeps out the area. And Kepler's Third Law formulated in the early 17th century. And you're right. So at the moment, it is moving relative to the sun at 0.9 kilometers per second. I always think in kilometers per second. So just short of 1 kilometer per second, which is actually much the same as the moon's orbit around the Earth. The moon moves at about 1 kilometer per second. But when it's at its closest, it whizzes by the sun at 54 kilometers per second. And that's because of this phenomenon. With any elongated orbit, it's very slow at aphelion, the furthest point from the sun, and very fast at perihelion, the closest point to the sun.
Okay.
So I'm glad you pointed it out, because I was going to mention it too.
Oh, good. When it turns around and starts coming back, does it do that in an arc, or does it just turn on itself and roll back, or how does it work?
So its path is an ellipse. Which is an oval, basically. So like a boomerang. But it's a very elongated. A boomerang's more of a hyperboloid, actually.
Oh, all right. Near splitting hairs. Oh, you can't, can you?
So no, I can't. That's true. I could. There's probably one or two if I could find them that might let me split them. So an ellipse is it's look, you know what it is. It's an elongated circle. It's an oval, and so if you just imagine one of those that's stretched out. So that you're quite right that it is highly curved at the two ends, at the two extremes. But it's not that it just slows down and falls back, although in a sense that's what it's doing. But it's still got its motion around the orbit.
Now, another thing I'm thinking is, it's 76 years between visits to the sun. Yeah. Is it an even split between the journey out and the journey back? I'm just trying to do the maths in my head.
No, it's not.
No, I didn't think so.
No, and it's not because of that. Certainly, in terms of the distance, I mean, it's in terms of time. Or let's do it the other way around. If it's halfway out to its perihelion, I think it is more than halfway in its time because its velocity in the inner part of its orbit is greater.
And yet.
Is that right? Have I got that the wrong way around?
I just did the math. I just did the math. And it's been 38 years since it was here.
That's correct. Yeah. Oh, I'm sorry. I misunderstood your question.
Oh, okay.
So what you're saying is the outward journey the same as the return journey
in time,
in terms of equal time? Yes, it is.
Okay, but distance-wise, it varies. Yes, that's correct. So there might be slight perturbations caused by the gravity of things like Jupiter that just make it a little bit different. But basically, the time from perihelion to aphelion is the same as the time back from aphelion to perihelion. Aha. All right, we've got it. Okay, well, we still got to be patient, though. 2061's a while away. I also read that anybody born in the 80s has a reasonable chance of seeing it or after.
Yeah, that's right. You'd be sort of in your 90s by then, 2061. If you were born in 1980, if you're born in 1991, clearly you'd be 70. So,
well, if it's 2061 that it's arriving, I'll be 99. I just worked that out. Okay. So that's.
Look, I reckon you're going to make it to 99. I did a talk this morning, which was a commemorative talk for one of my colleagues who was a very, very accomplished astronomical engineer who I knew quite well. His name was Hermann Wehner. He died in October at the age of 99, and he was doing orienteering until his 98th birthday. He was a mad, keen orienteerer. Yeah. But yeah, what a great life. And so I'll tell you, he's a role model for me. But even if I live to till I'm 99, that wouldn't be long enough for me to see Comet Halley, I'm afraid. How old were I?
Oh, well.
Wait a minute, I can tell you.
Not going to work it out, are you?
I would only be 100. I'd be 115, I think. Is that right?
Yeah, that'd almost be a world record.
It would, yeah, it would be. But I could tell you, I'm aiming for it. And
yeah, why not?
Give up that easily.
No, what? No, it should. Absolutely. Yeah. Okay. So it's on its way back. Is basically what we spent 15 minutes telling you. So it's all good news.
It's nothing like space nuts. Nothing like space nuts for spinning one piece of information out into half an hour.
If you want to read all about it, there's a good article on phys.org. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson. Let's just take a quick break from the show to tell you about our sponsor, NordVPN. And I'd like to send out a shout out to Nord for being such great supporters of Space Nuts. They've been with us for many months out of the last couple of years, and we really appreciate their support. So thank you so much. Of course, NordVPN is the one I use on my my iPhone, on my iPad, on my computer. It is such a useful device, and as a Space Nuts listener, of course, you have access to a really great deal courtesy of NordVPN. So just jump onto your device and put nordvpn.com/spacenuts into your browser, right? Enter that, and it will bring up a special page introducing you to NordVPN. And they've got a really exclusive Christmas deal going at the moment for Space Nuts listeners, where you can make great savings, but you'll also get an extra 4 months thrown in absolutely free. And you never should forget their 30-day money-back guarantee. They really do back their product, and they really are the best at a virtual private network and all the other stuff that comes with it. I mean, it's not just about a VPN, which is really useful when you're traveling, especially if you get in those public Wi-Fi areas. You switch your VPN on and you are secure. So you get that as a part of the deal. You get malware protection and the tracker and ad blocker, very good tools. But if you want to get more bang for your buck, and all their deals include that extra 4 months. Doesn't matter whether you sign up for the standard deal or go for one of the more intensive deals with all the extra bells and whistles. They're all going to give you the extra 4 months. But if you go intermediate level, you can add on the cross-platform password manager and the data breach scanner. But I went the whole hog over a 2-year period, which saved an absolute fortune. You can get a monthly plan, a yearly plan, or a 2-yearly plan. I went 2 years and I got everything. It's not going to cost you an arm and a leg. It's actually very inexpensive. And the longer you go with them, the lower the commitment on a month-by-month basis. So if you do go with everything, they'll throw in 1 terabyte of cloud storage, and we all need that these days with so much data being stored, and the next generation file encryption. Check it out for yourself, nordvpn.com/spacenuts. nordvpn.com/spacenuts. Click on Get the Deal. Check it out for yourself. At the very least, you want to secure your devices from anybody who wants to get your data, clean out your bank accounts, or just, muck around with your identity and sell it on the dark web, because that's what's happening a lot. And a VPN service can certainly secure you from those kinds of people. NordVPN.com/spacenuts. Check it out for yourself. And thanks again to Nord for being great sponsors of Space Nuts this year. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Our next story, Fred, is a real mystery, and that's because astronomers have discovered a first of a kind, which is what you do when it's a first of a kind, you discover it, stream of stars. What are we talking about here? What's it mean by a stream of stars? What I gather is that this is unusual in that it's in a place where it shouldn't be. That seems to be the gist of the story.
Yeah, you don't really need me for this because you've done it all. Thank you.
Oh, okay. Sorry. I'm still mystified, though, as to what it is, why it is, and where it is.
Okay, so let's think about star streams. And there are such things, and our galaxy has them. Although, once again, the stars in them have only just been discovered. It's been known for a long time because of the gas that's in it. This is what's called the Magellanic Stream. So, we've got the two clouds of Magellan in the southern hemisphere, the large and small clouds. They are basically being devoured by our own galaxy, the Milky Way galaxy. And so they're spiraling inwards, basically, over periods of tens of millions of years. And as they do that, they leave debris behind. And that debris is in the form of gas and stars. And so they leave behind what we call stellar streams, a stream of stars. And we can see those in other galaxies, Andrew. When we look at other distant galaxies, we can see them actually physically in the region of a galaxy. But here is one that has been discovered, and it's basically straight. It's a straight line, which stellar streams normally aren't. They're normally curved because they're behaving under the influence of a nearby galaxy. And this one is 10 times the length of the Milky Way's diameter. Blimey. So 10 times 100,000 light years. So this is big. It's a million light years or thereabouts across or along, and it's in a cluster of galaxies, a very well-known cluster of galaxies, actually called the Coma cluster, which is about 230 million light years from our own galaxy, and it's just showed up in images, really deep images taken of this cluster of galaxies. And it's actually quite interesting because it's a team of scientists who've been looking for signs of dark matter, and they've been basically looking for anything within this cluster of galaxies that might hint at the presence of dark matter, and it's usually the fact that you see gravitational distortions. I should explain they're from an organisation I used to work closely with, the Astrophysical Institute in the Canary Islands, where big telescopes are on the island of La Palma. Although the Astrophysical Institute is actually on Tenerife, just to be clear about the details, it's scientists there who were searching for the Coma cluster for evidence of dark matter. And what they found was this star stream, and more or less a straight line, as I said. And it's a puzzle as to how it's got there. Why are there structures like this in the universe? It's something that we've not really recognized before. It's one nice coincidence, by the way. Sorry to interrupt, Andrew. A nice coincidence is the Coma cluster was the cluster of galaxies in which dark matter was first discovered back in 1933. But nobody took any notice of the discovery because it just didn't make any sense.
Yeah.
Understand it.
Well, it still doesn't make much sense because we don't really know what it is. So this string of stars is positioned in a way that makes it so much different from the other strings of stars that exist, within galaxies. This one's in a very strange place, isn't it? It's odd.
Yes, it is. So it's in a cluster of galaxies, but it doesn't seem to be attached to any particular galaxy. Whereas all the stellar streams that we know about they're part and parcel of a galaxy, usually in what we call the halo of the galaxy, this kind of spherical shell of stars that surrounds a galaxy. For example, one with a disk like ours, the Milky Way. We have a halo, call it the galactic halo, around the Milky Way, and that's the place where you expect to find stellar streams. And as I've said, we do find them, not just one, but several of them in our own galaxy. The interesting thing is this is more or less linear. It's more or less a straight line. And so the suggestion is that what we're seeing is almost perhaps like a broken off stellar stream, one that's been going around another galaxy, but has somehow been disturbed by gravity to straighten it out and put it in deep space in among the other galaxies of the cluster.
It is stretched out between a bunch of galaxies. The Coma, they call this the giant Coma stream, but it's within that Coma cluster. Why aren't they affecting it?
They probably are. And this is what the real puzzle is. Actually, there's I mentioned the Astrophysical Institute in the Canary Islands. One of the scientists is actually at Groningen in the Netherlands. And that astronomer basically has said you would expect finding, a stream of stars like this, that it will be ripped apart by the gravity of all these other galaxies. And so nobody really knows how it's managed to stay intact and how it's grown so large. And the explanation they're looking at is possibly dark matter, that there might be dark matter that is somehow, its gravity is somehow shepherding this giant Coma stream to render it more permanent than it otherwise would be, because you'd expect it to be torn to bits. The interesting conjecture is: are there other examples of this? What do they look like? Are there other examples in the Coma cluster? Should we be taking deeper and more sensitive images of this cluster? And what might we might find if we do? So that's the sort of ultimate prognosis of this.
So what they're saying is, we were looking for information and evidence of dark matter. We found a weird string of stars that are, it's 1 million light years across. They shouldn't be like that, but it could be caused by dark matter. That's exactly what they're saying.
That's exactly what they're saying. That is exactly it in a nutshell. And it's, of course, the technologies that dark matter scientists have at their disposal in terms of numerical calculation as well as particle accelerators. That's remarkable technology. So I think there might be some, you never know, there might even be some AI applications that could be used to actually work out whether dark matter could be causing a stream of stars like that. So I'm sure we'll hear more about it, the giant Coma stream.
Yes.
Forget about that.
The imagery from the William Herschel telescope, which was the one focused on this, is just remarkable. Yeah. Really worth looking at.
I used to work on that telescope. That's what took me to the Canary Islands.
There you are.
Yes. So it's an interesting. It's a really good telescope, and also in an interesting location with other interesting instrumentation, which is what I was involved with. So great to have that William Herschel telescope image showing this strange stream of stars. It's kind of, there must be a Christmas link here, or a festive season link, because we have streamers, don't we, for around Christmas trees?
Yes, we do. Yes, that's right. And lots of tinsel. This is a tinsely looking photo.
It is. Yes, it is. Very tinsely.
Yeah. If you want to take a look at the giant Coma stream online, it's at the space.com website. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
Sorry about the pause. I had the wrong screen set up. I was going to do something silly, and, that's so unlike me.
I'd rather say one.
Yeah, that's what I was trying to do. Let's see if we can answer some audience questions, Fred, because we do that in the third segment usually, and we've got a bunch of stuff to get through today. And our first question comes from Ash.
Hi, Fred and Andrew. Ash from Brisbane here. Just wanted to share my thoughts on the boat, brightest object of all time. Just seems to me that a million solar mass black hole with no galaxy around it is a bit weird. And the fact that it's devouring a huge gas nebula it just seems a bit odd to me. I reckon, in my personal opinion, that this could be the first witnessed event of a white hole. What are your thoughts? It could be a black hole on the other side of it devouring something, and the beam of gamma radiation being spat out the white hole directly in our direction. What are your thoughts? Thanks, mate. Bye.
Thanks, Ash. Intriguing idea. We better firstly explain what the boat is for those who haven't heard us talk about it previously. We have mentioned it a couple of times. I think it came up again 1 or 2 episodes ago.
It did.
So, we better, again, just explain what the boat is. Was it the brightest of all time, was it?
Yeah, brightest of all time. And its gamma ray burst, I think it was October 2022 when it occurred.
That's the one that punched the hole in our ozone layer.
In the ozone layer, that's right.
That's right.
It was so strong. Distance, if I remember rightly, 1.9 billion light years. But was enough oomph to it to actually... It may not have punched a hole in it. I think it wobbled it a bit.
Yeah.
But still a remarkable occurrence. And whereas most gamma ray bursts last a few seconds, this I think went on for 7 minutes. So this huge amount of energy that's been released, exactly as Ash says. And I do like his thinking there about white holes, but I'm not sure about his premise about there not being a galaxy around it, because gamma ray bursts are usually associated with basically exploding stars, massive supernova explosions. So there might be a cross line there, which I'd need to think about a bit more as I remember what our discussion was. But it's a gamma ray burst, and it is true that I think astronomers still do have an open mind about white holes, because the mathematics says that if you reverse the time parameter in the relativistic equations for a black hole, you get a white hole, something that's spewing out material.
Yeah.
Stuff can leave it, but nothing can go into it. And so astrophysics doesn't rule that out. But the fact is that we've never found anything like that. So I think I like his thinking. I suspect there are aspects to it that don't match what we would expect from a white hole. But watch this space. Yeah.
Well, we are watching that space because we're trying to figure it out. But we don't know what caused it, do we?
Well, no, that's the thing. We imagine that it's a standard, very high energy explosion. That's the usual cause for a GRB, gamma ray burst.
Yeah, it just hit us. That's the thing. Took a while, but it got here.
Yeah, it took 1.9 billion years to get here, and then rattled the atmosphere. It's scary, isn't it, when you think what that might have done had we been within 1.9 million light years of it. That would have been a different kettle of fish.
Yeah, it does sort of make you pause when you think about that awesome power so far away still being able to affect us. And you've got to wonder if something's sort of brewing closer. Sorry to sort of burst everyone's bubbles, so to speak. Thank you, Ash. And great question, well thought out. Let's go to a text question now. And this one comes from Daryl in South Australia. And Daryl says, "G'day, gentle, hairy men." Okay.
Speak for yourself.
I haven't shaved today. I'm a long-time listener, Patreon subscriber. Thank you very much, Daryl. We appreciate that. And he says he's also an occasional question asker. Why, in a universe of such extremes and vast emptiness, does absolute zero, 273.15 Celsius, or 459.67 degrees Fahrenheit, even exist? Given that a star is thousands to millions of degrees, why is there a limit on cold temperatures? Is there a limit on hot temperatures? Absolute hot. And while I'm in the question asking mode, is there an absolute heavy and an absolute light? Keep up the more than adequate job. Thanks, Daryl. It's a good question, though. We always, you hear the term absolute zero all the time in science. Is there an absolute, other end of the scale?
In some ways there is, but absolute zero is a bit special, though, because that's the temperature at which all atomic motion stops. So atoms are in a state of vibration when they're heated, but when they cool to that temperature, minus 273 degrees Celsius, all motion stops, and that's why you can't go any colder if you're talking about measuring the temperature of a substance, which is kind of what you mean. At the other end of the scale, there are temperatures above which things become ionized. I don't think there's a limit, though. I think you could keep on heating things till they become a soup of separate electrons and protons, which is more or less the state of things in the Big Bang, when the Big Bang occurred. So maybe the temperature of the Big Bang is the ultimate limit. Whatever it was certainly many tens of millions of degrees, probably more like hundreds of millions of degrees. But it doesn't have the same physical significance that absolute zero does. Likewise, absolute heavy and absolute light, you could reinterpret that as saying, well, it's about density. Is there an absolute maximum for density? And yes, that's infinite, which is what a black hole is.
Yes.
So, in that regard, we've got a limit there. Is there a minimum density? Well, I suppose it's nothingness, really. That's something with a zero density, grams per cubic centimeter, or whatever units you use. So none of those have the same kind of physical significance of absolute zero.
Just to throw a curveball, because that's what I like to do, we define absolute zero, as Daryl said, as minus 273.15 degrees Celsius. But that's just a number created by humans in terms of measurement, isn't it? Or is there a reason why it's that number? Is there some other science to it?
Yeah, it's you're right. It's arbitrary. So absolute zero is a physical state to be in when atomic motion ceases. The reason why we measure it in Celsius is that Celsius was the best temperature scale that was produced in the 19th century, and it relates to the properties of water because it's zero when things are frozen, and it is basically 100 when things are boiling. So it's the range of temperatures within which water exists as a liquid, which is not related to absolute zero, which is why there's this random number, minus 273.15 degrees Celsius is where atomic motion stops. It just so happens that 273.15 degrees Celsius warmer than that is where water or ice melts, basically, where ice turns to water.
Okay. So why do we measure things in Kelvin? Has that got to do with the extremes of temperature?
Yeah, Kelvin is the same scale as Celsius, but it starts with absolute zero. So 1 degree Kelvin is, basically minus 272 degrees Celsius. That's 1 degree Kelvin.
All right. So it's just sort of reduced the impact of the numbers.
So the reason why that's useful is it takes water out of the equation. You don't need to worry about, because Celsius is hinged on the properties of water. Kelvin is much more absolute. It's an absolute temperature scale because it starts with absolute zero.
You're going to upset the Americans by saying Celsius is the best measure of temperature because they don't use it. But I do understand that when the Celsius scale was developed by Celsius himself,
Anders,
yeah. He actually did it in reverse. He measured the cold at 100, the freeze point at 100, and the maximum at 0, didn't he? I read that somewhere. Is that an urban myth?
I think you're right. I think that's right. Yes, I'd forgotten that, but I think you're right that it was the wrong way around.
So somewhere along the line, someone went, hang on, it doesn't make sense. The freezing point should be naught, and they flipped it.
I think that's correct. Our non-viewers won't be able to see this, but this is a napkin from mine and Marnie's favourite restaurant in Oslo, Cafe Celsius.
Oh, wow. That's a good one.
Yeah, I've always thought it was worth saving because it's a very nice cafe, but I like the name.
I do,
even
too.
though Anders Celsius was actually Swedish, but he's got a cafe in Oslo.
Close enough.
I hope it's still there. Yeah, I hope it's still there.
Yes. Thank you, Daryl. Let us go to another question, and this is an audio question from Pete here.
Hi, Fred and Andrew. Pete here from Mumble Point on the shores of Lake Macquarie. Recently heard you talking about the impending collision of the Andromeda and Milky Way galaxies. But I reckon I'm pretty confident. I've heard that the expansion of space is occurring at an even greater speed, meaning that in fact we'll never see Milky, or whatever term Andrew wants to use. So my question is, which speed will win out?
Thank you, Pete. Lovely part of the world, Lake Macquarie. Spent a lot of time there in my youth, and my brother still lives in that part of the world, I believe. Well, he moves around a lot, so I'm not sure now. Pete's come up with an interesting theory here. The expansion of the universe negating the collision between our two galaxies, Andromeda and the Milky Way. It was Milkomeda, I think we were calling it, Pete.
Milkomeda, that's right.
And surprisingly, that last discussion we had about it has spawned the same question or a similar question from 3 different sources. So we can knock off 3 questions in one hit here.
Very good. And the answer is no.
I knew it would be.
Yeah, it's always no, isn't it? Except when it's, just about adequate. The bottom line is the separation of the Andromeda galaxy and ourselves is 2.5 million light years. Which is negligible when you come to look at the expansion of the universe. We look at the expansion of the universe on scales of kilometers per second per megaparsec, and a megaparsec is 3-point-something million light years, and so that to basically what I'm saying is the amount of expansion is very low compared with the gravitational pull that's pulling them together, which is in the region of 200 and I think if I remember rightly, it's about 270 kilometers per second, their approach speed, which is far more than they're being carried apart by the expansion of the universe. So the collision will happen. I keep telling people to put it in their diaries. Yeah, it's going to happen.
Yes, and one of the other questions that came in suggested that the space between the galaxies was what is expanding and not the galaxies themselves, therefore they can't collide. But that's not true, is it? I mean, everything's expanding. Even our houses are moving apart based on this science, but it's just so minuscule we'll never see it.
Yeah, that's right. Actually, that's not quite true because on the scale of a planet, the gravitational bounding of the planet, the fact that it's got gravity which pulls everything down, that is vastly more effective than the expansion of the universe trying to pull it apart, because you'd be talking about tiny amounts of expansion over the width of a planet, and planets are gravitationally very strong. So I was going to just make a clarification, because galaxies. So yes, the universe is expanding and galaxies are being carried along with that. We call that the Hubble flow, and it's kind of analogous to the flow of a river. but also analogous to the flow of a river is if you think of people in boats moving around on the river, their motion is superimposed on the flow of the river. So they've got their own motion. And as galaxies do, we call it the peculiar motion of a galaxy. That's because it's peculiar to that galaxy itself, and it's not because it's being carried along by the expansion of the universe. And in the case of the Andromeda and Milky Way galaxies, their peculiar motion is such that it'll bring them together, despite the Hubble flow trying to keep them apart. The Hubble flow is much, much lower than the gravitational pull pulling these two galaxies together.
Okay, there you are, Pete. And the other people that sent in questions of a similar ilk, no, the collision will happen. Simply because of, there's all sorts of different sciences going on here, but one negates the other. And yes, it will happen. So, as Fred said, put it in your diary. Thanks, Pete. Lovely to hear from you. Let's it's the last program of the year before we go into repeat mode. And I thought, last year we finished off with a song. This year, I'm going to regret this. We're going to finish with a dad joke.
Hello, Space Nuts. Martin Berman Gorvine here, writer and pest extraordinaire in many genres, including dad-type jokes. And here is one such, inspired by the dizzying rotation of Sagittarius A star, as described in episode 379. So we're going to do this Jeopardy style, right? So you get the answer first. And the answer is something so dense, even I can't escape it. And the question, as you can probably guess, is what do you get when you have a black hole that is rotating so rapidly it shakes itself to pieces? Now, why does that generate the answer? Something so dense, even I can't escape it? Why? Because the word light also gets shaken to pieces, and one of those pieces is I.
Oh, dear.
Can't wait to hear your groans. Berman Gorvine of Potomac, Maryland, USA here, over and out.
Oh, Martin. As far as dad jokes go, well thought out, but absolutely hideous. But it does deserve one of these. There we go. In terms of dad jokes, he put a lot of science into that. I'll give him credit for that. Fred, we are done for another show. We're done for another year. Just want to say thank you to you for making yourself available so often. And this has been a tough year because we've both spent a lot of time away and have had to basically cram to get every week's episode out. I think at one point there we went 7 weeks without recording, but no one would have noticed. So we got them all lined up and all into the system, and it was a great effort. Thank you very much.
It's a pleasure, Andrew. You've had a fairly tough year as well, and hopefully all is going well. You've moved house. You've done all kinds of things.
Oh yeah, I've had an interesting year. The Chinese say, may you live in interesting times. Well, yeah, okay, major operation, moving house, lots of job changes, finished up at the Salvation Army the other day. It's all happening. Hopefully next year will be much more smooth.
And yet you've fitted in 47 episodes, I think it is, of Space Nuts.
It might have been, yeah. Might have been.
So well done. And thanks for your company every week. It's definitely a milestone in my weekly diary that I'd be very upset to have to miss. So we'll keep going, and long may Space Nuts rule the airwaves.
Yes, and the universe. That's what we're aiming for. We want to dominate the universe. Thanks, Fred. Much appreciated. Also want to say thank you to you, the listeners, for everything that you do. The fact that you support us is what's kept us going, and there are many thousands of you, and I don't know most of you, but we do have our regulars, and we appreciate them. We appreciate our patrons who put their money where our mouths are, and we still can't believe that people do that just for the love of it. So thank you so much to our patrons. And I know I give him a bit of stick every week, but thanks to Hugh in the studio. It was late again today, but that was our fault because we changed the time but didn't tell him. But he works so hard behind the scenes to get everything out there into the ether, and it's certainly greatly appreciated. So thank you, Hugh. And that wraps it up for this year. The next couple of weeks will be repeat episodes of our popular Q&A shows where everything's just audience questions. So there's a couple of really good ones that we thought we'd run again from early in 2023. Until we get back in the new year, we wish you and your family and everybody a very Merry Christmas and a Happy New Year. Salutations and celebrations. And until next time, thanks for listening to Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Complete Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.